Every year, the Amazon is drenched in about 8 feet of rain. In some parts of the forest, the annual rainfall is closer to 14 feet, more than 5 times the average yearly precipitation across the contiguous United States. This deluge is partly a consequence of geographic serendipity. Intense equatorial sunlight speeds the evaporation of water from sea and land to sky. Trade winds bring moisture from the ocean, and bordering mountains force incoming air to rise, cool, and condense. Rainforests happen where it happens to rain. But that's only half of the story. Within the forest floor, vast symbiotic networks of plant roots and filamentous fungi pull water from the soil into trunks, stems, and leaves. As the nearly 400 billion trees in the Amazon drink their fill, they release excess moisture, saturating the air with 20 billion tons of water vapor each day. At the same time, plants of all kinds secrete salts and emit bouquets of pungent gaseous compounds. Mushrooms, dainty as paper parasols or squat as doorknobs, exhale plumes of spores. The wind sweeps bacteria, pollen grains, and bits of leaves and bark into the atmosphere. The wet breath of the forest, peppered with microscopic life and organic residues, creates the ideal conditions for rain. With so much water in the air and so many minute particles on which the water can condense, clouds quickly form. Certain airborne bacteria even encourage water droplets to freeze, making clouds bigger, heavier, and more likely to burst. In a typical year, the Amazon generates around half of its own rainfall. Ultimately, the Amazon rainforest influences much more than the weather above its canopy. All the water, biological detritus, and microscopic beings discharged by the forest form a massive floating river, an aerial echo of the one snaking through the understory. This flying river brings precipitation to farms and cities throughout South America. Some scientists have concluded that, due to long-range atmospheric ripple effects, the Amazon contributes to rainfall in places as far away as Canada. A tree growing in Brazil can change the weather in Manitoba. The Amazon's secret rain ritual challenges the way we typically think about life on Earth. Conventional wisdom holds that life is subject to its environment. If Earth did not orbit a star of the right size and age, if it were too close or too far from that star, if it did not have a stable atmosphere, liquid water, and a magnetic field that deflects harmful cosmic rays, it would be lifeless. Life evolved on Earth because Earth is suitable for life. Since Darwin, prevailing scientific paradigms have likewise emphasized that the ever-shifting demands of the environment largely dictate how life evolves. Species best able to cope with changes to their particular habitats leave behind the most descendants, whereas those that fail to adapt die out. Yet this truth has an underappreciated twin. Life changes its environment too. In the mid-20th century, when ecology established itself as a formal discipline, this fact began to gain wider recognition in Western science. Even so, the focus was on relatively small and local changes. A beaver constructing a dam, for instance, or earthworms churning a patch of soil. The notion that living creatures of all kinds might modify their environments in much more dramatic ways, that microbes, fungi, plants, and animals can change the topography and climate of a continent or even the entire planet, was rarely given serious consideration. To a large extent, the physical form and the habits of the Earth's vegetation and its animal life have been molded by the environment, Rachel Carson wrote in Silent Spring in 1962. Considering the whole span of earthly time, the opposite effect, in which life actually modified its surroundings, has been relatively slight. E.O. Wilson declared something similar in his 2002 book, The Future of Life. Homo sapiens has become a geophysical force, the first species in the history of the planet to attain that dubious distinction. When I first learned about the Amazon's rain dance, I was both enthralled and bewildered. I knew that plants pulled water from the ground and expelled moisture into the air, but the fact that trees, fungi, and microbes in the Amazon collectively conjured so much of the rain for which their home was named, that life's activity on one continent altered weather on another.